You know that feeling when your phone unlocks the instant it sees your face? Or when your favorite streaming service suggests a movie that's, well, just perfect for you? That's not magic. It's an incredible technology working behind the scenes. And today, we're going to pull back the curtain on the digital brains that make it all happen: neural networks.
Seriously, think about it for a second. How on earth does a little device in your pocket know your face from millions of others? How can it do that in a split second? It feels impossible. But what's really going on is far more interesting than just plain magic. The secret is that we've essentially built a digital brain. It's a system that's directly inspired by the most powerful computer we know of, our own brain. We've designed it to learn, to see, and to recognize patterns in the world, pretty much just like we do.
And this digital brain has a name, of course: a neural network. At its heart, it's a web of interconnected digital neurons that don't need to be programmed for every single task. Instead, they learn from data, from experience. This very idea is the absolute foundation of what we call deep learning.
Okay, so what's actually going on inside this digital mind? It's not just a messy jumble of code. It's actually a pretty elegant structure, a three-part journey that takes raw, messy information and turns it into a smart, clean decision.
So, everything kicks off at the input layer. Think of this as the eyes and ears of the system. It just takes in the raw data, like the thousands of pixels that make up the image of your face. From there, that data flows into the middle, into the hidden layers. Now this is where the real thinking happens. The more of these layers you have, the deeper and more complex the network's understanding gets. And finally, after all that hard work, we arrive at the output layer. This is the part that gives the final answer, like, yep, that's definitely you, or nope, this email is 100% spam.
To make this super clear, imagine you're teaching it to read sloppy handwriting. The first hidden layer doesn't see the number 8, not at all. It just sees simple things, like little lines and curves. Then the next layer learns to put those together into basic shapes, like circles. A deeper layer then spots the pattern of one circle stacked on top of another. And finally, the output layer puts that all together and says with confidence, that's an 8. See, it's learning, building up from the tiniest details.
But here's where it gets really powerful. These digital brains aren't just handed the answers. They have to learn. And just like for us, probably the most important part of learning is, well, it's messing up. It's all part of this constant learning loop. First, the network takes a guess. This is called forward propagation. It sees a picture of a cat and says, I think that's a dog. Next, it calculates its mistake, or its loss. It checks the right answer, sees it was cat, and realizes, oops, I was wrong. And then comes the truly genius part: backpropagation. The network sends that error message all the way back through its layers, basically telling each neuron, hey, we messed up. Tweak your settings just a tiny bit so we get it right next time.
It is exactly like practicing a math problem. Every single mistake you make isn't a failure, right? It's a clue that helps you get just a little bit closer to the right answer. Now just imagine doing that millions of times, every single second. Through this relentless process of trial and error, the network gets sharper and sharper until it becomes incredibly accurate. Now, you wouldn't use a hammer to turn a screw, right? Well, it's the same idea here. You don't use the same kind of neural network for every single problem. There's a whole family of them, and each one is a specialist, built for a different kind of job.
For your basic, straightforward tasks, you've got RNNs. But for anything visual, images, videos, you need a specialist. That's a CNN, the powerhouse behind facial recognition. For things that happen in order, in a sequence, like speech or text, you use an RNN. And then you have the heavyweights, the new titans of AI, transformers. These are the unbelievably powerful engines driving things like ChatGPT and Google Translate.
And because there are all these different specialists, these networks are working all around you, totally unseen. They're helping doctors spot diseases on scans, they're protecting your bank account from fraud, and they're translating languages in real time so you can talk to almost anyone on the planet. They've quietly become essential. So, here's the real takeaway. Neural networks are not some niche, futuristic technology anymore. They are the fundamental backbone of modern artificial intelligence. They are the engine inside almost every major AI application you interact with every single day. But, and this is a really important but, with all this incredible power comes some equally huge challenges. This technology isn't a magic wand, and it's so important that we understand both its amazing strengths and its very real limitations. So,
On the one hand, their ability to learn and adapt makes them astonishingly good at what they do. But wow, they have a huge appetite. They need enormous amounts of data and some seriously powerful computers to run. And then there's the biggest challenge of all. They can be a total black box. Information goes in, a decision comes out, but sometimes we can't really explain why it made that choice. And that leads to a really massive question for all of us. When these systems are making life or death decisions in medicine or huge financial choices, if we can't fully understand their reasoning, how much can we or should we really trust them?
So, we'll leave you with this one last thought. We are building digital minds that learn from the world that we show them, a lot like a child does. And that leaves us with maybe the most important question of all. If this AI is learning from us, what exactly are we teaching it? Thanks for watching.